Buckle up, because we're about to take a wild ride into the future of automotive engineering. Picture this: a motor smaller than your average watermelon, yet packing enough punch to leave traditional engines in the dust. That's the Koenigsegg Quark E-motor for you, a true David among Goliaths in the world of hypercars. Now you might be thinking, electric motors? Been there, done that. But hold on just a minute, because the Quark isn't your run-of-the-mill electric motor. We're talking about a powerhouse that's not only compact, but also boasts a mind-bending 330 horsepower. And if that's not enough to get your heart racing, how about this? Koenigsegg didn't stop at just one motor. They went ahead and doubled the fun with the Terrier. Combine these two marvels with a single inverter, and you've got yourself a jaw-dropping 660 horsepower package that weighs less than a small suitcase. That's right, folks. We're talking about supercar performance that you can literally carry on your back. But what's the secret behind this miniature marvel? How did Koenigsegg manage to cram so much power into such a tiny package? Join us as we peel back the layers of innovation and dive deep into the revolutionary technology that's making waves in the automotive world. From advanced materials to cutting-edge design, the Quark E-motor is rewriting the rulebook on what's possible in the realm of electric propulsion. So, whether you're a gearhead craving the thrill of blistering acceleration or an eco-conscious driver looking to leave a smaller carbon footprint, the Koenigsegg Quark E-motor is here to redefine your expectations. Get ready to experience the future of driving, where power, efficiency, and innovation collide in one electrifying package. You are wondering how they managed to fit all that power into something so small. Well, that is the magic of Swedish engineering. Koenigsegg has managed to create an electric motor that is not only efficient, but also incredibly powerful and remarkably portable. The secret lies in the design of the motor itself. Before delving into the juicy bits of how this astonishing production works, a short trip should be taken down memory lane to revisit the history of Koenigsegg. The year was 1994, when a young 22-year-old Christian von Koenigsegg decided to pursue his lifelong dream of building the world's largest super sports car. Down the line, the first Koenigsegg creation was born after 2 years of hard work, and it was a hit. In 2002, Christian's dream finally came true when Koenigsegg's first proper production car was unveiled, and it was a game-changer. The Koenigsegg CC8S's engine was certified by Guinness World Records as the most powerful engine in a mass-produced car in the whole world. Furthermore, the engine was based on a Ford V8, but Koenigsegg reworked it. Now, back to Koenigsegg's tiny Quark E-motor. Quark is a marvel of engineering that is perfect for a wide range of applications such as aerospace, marine, and EV powertrains. To come up with this groundbreaking motor, the brilliant minds at Koenigsegg combined two fundamentally different motors into one unique design. Speaking of magnetism, which is a crucial part of how electric motors work, Koenigsegg has innovatively combined two methods to create the Quark E-motor. They call it Raxium flux, which sounds made up because it is. What Raxium flux is made of is a fusion of radial and axial flux, two different ways electric motors usually function. For the layman, imagine you have coils that rotate between magnets, and depending on which way they go, the axial does it along the axis that is more perpendicular, and the radial does it running outside the weight. Radial flux motors are cheap to create and widely available in EVs, but they need more revs to produce peak power. On the other hand, axial flux motors offer more torque at low revs, but require lightweight and extremely durable materials to withstand a lot of stress. By combining these two motors, Koenigsegg has created a class-leading torque to power RPM to the weight matrix, making the Quark E-motor a powerhouse in a tiny package. The Quark E-motor weighs a mere 30 kilos, which is lighter than the motors Tesla used in its everyday models. To explain in simple terms, it is about the same weight as a giant otter, a double radiator, a bear cub, a garden bench, and a pair of speakers. Indeed, that is impressive. The Quark produces an astounding 335 horsepower and 443 pound-feet of torque. However, It is good to keep in mind that the peak power lasts for about only 20 seconds before dropping to 134 horsepower and 184 pound-feet of torque. Nonetheless, that is more than enough power for most applications. According to Andras Shekeli, the e-motor development lead at Koenigsegg, this motor is made of some seriously cool stuff. The shaft is made of 300mm steel that is used in motorsport and aerospace, which is a fancy way of saying it is really strong and light. Tesla's, it has been designed to work in conjunction with an internal combustion engine, and not just any engine, but the Koenigsegg Amara's TFG engine. The Amara's TFG engine uses its super cool camless free valve technology. If you are familiar with Koenigsegg, you'd know that they like to do things quite differently than everyone else. From their crazy horsepower to their wild doors, they are always pushing the boundaries. The TFG engine is no exception, as it is a relatively small 2-liter twin-turbocharged 3-cylinder powertrain. Nonetheless, when combined with the electric motor on the crankshaft, it produces a whopping 600 brake horsepower for the front wheels. And for the rear drive, there is a single electric motor on each of the rear wheels. The Camaro has 4 seats, 8 cup holders, and a combined output of 1,700 horsepower, which is just jaw-dropping. The Quark E-motor is the key to making all of this work together, like a tiny little Swedish tag team. The idea is that the e-motor will handle the low-down grunt for instant acceleration, while the combustion engine kicks in for the top-end punch. According to Koenigsegg, all of this means that the Camaro will effortlessly surge to a top speed of 248 miles per hour, but the auto company is not stopping there. Along with the Quark, they have also announced the Terrier, which will find its way into completely electric models. Despite its small size and weight of only 85 kilos, the Terrier is capable of a whopping 660 brake horsepower, and it is a torque vectoring unit, which means it can electronically vary the torque and send it to each wheel for better handling. It is like a tiny, energetic, and fearless Terrier that is ready to take on anything. For the future of cars, this means the Koenigsegg is pushing the boundaries once again and paving the way for a new generation of cars. With the Quark interior, they can combine the best of both worlds, which are the instant acceleration of an electric motor and the top-end punch of a combustion engine. Additionally, with the Gemera plug-in hybrid model and other future PHEVs, one can only imagine what they will come up with next. It might intrigue you to learn about some of the numerous cars produced by Koenigsegg. The low drag in combination with a frontal area of 1.88 square meters, in combination with a power level of a minimum of 1,600 brake horsepower, make the Jesco Absolute destined to achieve higher, more extraordinary speeds than any Koenigsegg or any other fully homologated car before it. Looking at the math and our advanced simulations, this monster will be unbelievably fast. The design and aerodynamics of the Jesco Absolute is one for the books. A peek into the design and aerodynamics. The Jesco Absolute presented a rigorous exercise in smoothing out surfaces on the car to remove any form of drag-causing elements while adding rear volumes that streamline the airflow. Over 3,000 hours have been invested in fluid dynamics, which is computational fluid dynamics, also called CFD, and aerodynamics analysis, alongside over 5,000 hours of design and engineering for the Jesco Absolute, on top of the Jesco. The CFD team meticulously went over every inch and design detail of the car, defining the elements needed to get to the drag coefficient even lower than the target of 0.28 cadmium, to just 0.278 cadmium. The most obvious character when looking at the Jesco Absolute is the removed massive rear wing. The wing is removed to reduce downforce and drag, dropping downforce from 1,400 kilograms to 150 kilograms. In the concept of every vehicle is handling. The handling of this beautiful creation is as captivating as it gets. Comfortable car looking more like Formula 1. Koenigsegg uses the industry's longest front and rear wishbones, more similar to Formula 1 racing than the typical road car. Enlarged wheel bearings in lightweight housing provide an unrivaled mix of responsiveness and stability,